In this video, we're going to have a look at using the quotient rule to then find the stationary points of this curve, as well as the nature of the stationary points, which just means whether the stationary points are maximum or minimum or points of inflection. So just a little reminder. As this here, and here are stationary points. This one is a maximum one, where dy dx is 0 because it's a stationary point, but on top of that, the second differential is actually less than 0. This is a minimum point where, because it's a stationary point, dy dx again is equal to 0, but the second differential this time is actually going to be bigger than 0. And the last one is a point of inflection. That's where dy dx is equal to 0, but also the second differential is equal to 0. So in all three of these cases, what we see is that dy dx is equal to 0. That's what we have to do first. We have to first find dy dx, make it equal to 0, and solve that equation that we get. From there, we're going to define the second differential and check whether it's equal to 0, whether it's positive or whether it's negative, and then determine the nature of the stationary point from there. So let's take it step by step. Step number 1, we're going to find dy dx. So when a function is written in terms of u over v, where it's one function divided by the other, you call the top function u and the bottom one v. Before we can do the rest of this question, we need du dx and dv dx. So let's find that. We differentiate u with respect to x, which will get you to 1. We differentiate v with respect to x, and that will get you to 2x. From there, you can pretty much just plug it into this equation. So we have that it's v, which is 9 plus x squared, multiplied by du dx, which is 1. Take away u, which is x, multiplied by dv dx, which is 2x, all divided by v squared. Now v squared is just 9 plus x squared, all squared. So let's write that out. Now 9 times 1 is just 9, x squared times 1 is just x squared, minus x times 2x is minus 2x squared. That will just all simplify to 9 take away x squared, all over 9 plus x squared, all squared. Now we mentioned that we're interested in the stationary points, which is where dy dx, what we just found, is equal to 0. So I'm just going to write here that this is dy dx. It's equal to this, and then this is equal to 0. Now if you think about a fraction, you can never divide by 0, so the denominator can never be 0. So when is this fraction equal to 0? It's when the top of the fraction, the numerator, is actually equal to 0, because 0 divided by anything is 0. So we can just solve this and say that's the solution to this. Now when solving this, you add x squared to both sides, so you get x squared equals 9, and then you square root both sides. But when you square root, remember that there's a positive and a negative square root. The root of 9 is 3, so the answer is positive or negative 3. So there's two stationary points, either when x is minus 3 or when x is positive 3. Let's find the y coordinates at each of those points, because it is asking for the coordinates of the stationary point, both x and y. To do that, we know that both these points are on the curve, so we just put x equals minus 3 into this equation of the curve, and put x equals 3 into the equation of the curve as well. Let's do minus 3 first. So y equals minus 3 over 9 plus x squared. X squared will be minus 3 all squared, which is 9 again, which is minus 3 over 18, which is minus 1 over 6. So I'm just going to write that out quickly. Minus 1 over 6. Now when you put positive 3 into this equation, you get y is equal to 3 over 9 plus 3 squared, which is 9. 3 over 18, which is just, again, 1 over 6. Oh, sorry, it's not again 1 over 6. Before it was minus 1 over 6. But, so here it's minus 1 over 6, and here it's 1 over 6. Perfect. It's also asked for the nature of these stationary points. So how we do that is I'm going to change the color of the pen actually, because it's quite a big question. You have to find the second differential, which is what you get to when you differentiate dy dx. So dy dx we found was this. We now have to differentiate all of this to get d squared y over dx squared. Let's do that. So once again, we're going to use the quotient rule because we're doing one function divided by another function. We call the top function u this time, so 9 minus x squared. And we call the bottom function v, which is 9 plus x squared all squared. You're probably starting to see why this is a 7-mark question now. There's so many steps involved. 9 plus x squared all squared. Du dx in this instance would be what you get when you differentiate well, 9 differentiates to 0, minus x squared differentiates to minus 2x, so that's that. And dv by dx, here you use the chain rule, and I'll show you the quick way of doing it. So you take the power and you multiply by the coefficient before the term. You then differentiate it inside of the bracket, which is 2x. You then write out this whole bracket, but then subtract 1 from the power. So it's like 9 plus x squared all to the power of 1. 2 times 2x is 4x. So that's 4x multiplied by 9 plus x squared. And here you can multiply out the brackets because this is just the power of 1. I'm not going to actually though, because it's just going to... Actually, I might as well. Okay, so 4x times 9 is 36x. 4x times x squared is 4x cubed. It's going to get a little bit messy, but let's combine them together. We have v du dx, which is all of this times all of this, minus 2x and 9 plus x squared, all squared. Take away u dv dx, which is this multiplied by this. So you don't need to expand any of this out because we're just using it for substitution later on, which I'll show you how to do. All divided by v squared, which is just this all squared. But when you square a power of 2, it becomes a power of 4, so it just becomes 9 plus x squared all to the power of 4. Now what we're trying to do is we're trying to put x equals minus 3 and x equals 3 into this d squared by over dx squared, and we're trying to determine whether it's positive, negative, or equal to 0. So let's first put x equals minus 3 into this. So at the coordinate minus 3 minus 1 over 6, d squared y over dx squared is equal to, so then we replace everything where there's x here with minus 3. So I'm just going to do it on my calculator quickly. Just give me a second. It's going to take a little bit of a time to type out. 9 plus 9 is 18 squared minus... Okay, that whole second term just actually equals 0 because minus 3 all squared is 0 and 9 take away 9 is 0. 0 times anything is just 0. So that helps a lot. Then we're dividing by 18 to the power of 4. Now it does get you 1 over 54, but all that we're interested in is that it's actually just bigger than 0. So do you remember I said before that when d squared y over dx squared is bigger than 0 and dy dx is equal to 0, which it is at this point, this is a minimum point. That's the nature of this point. Let's now do the same for the other coordinate, which is 3 and 1 over 6. Once again, the second term will actually just equal 0 because when you put x equals 3 into this, 3 squared is 9, 9 take away 9 is 0, and 0 times anything is just 0. So you basically, yeah, let's just put it in. Minus 2 multiplied by positive 3, then in brackets. Okay. In this case, you'll get that it's minus 1 over 54 actually. Again, we're just interested in the fact that it's negative. So because it's negative, that means that this coordinate here would give you a maximum point. Yeah. Hopefully that all made sense. So we not only went through how you can use the quotient rule, but how you can find coordinates of stationary points and also determine the nature of the stationary points, whether they're minimum, maximum, or points of inflection. If you have any questions with it, just let me know in the comments. Otherwise, yeah, be sure to like the video if it helped, and I'll post more difficult questions on quotient, chain rule, and product rule in the near future, so be sure to keep a lookout.